Now we're going to discuss in details about the framework for Priceline. We are starting with the folder structure. We are not covering KeyBank in this video. We are only covering Priceline's automation framework structure and overview. So I'm going to explain the folder structure in spoken English now. It's a hybrid framework built with Selenium WebDriver, Java, and TestNG, fully integrated into our GitLab CI/CD pipeline. At a high level, the framework follows a modular design, and the main folders are organized under the standard Maven structure with SRC Maven Java for framework components and SRC Test Java for test execution. Number 1. Config folder. This folder holds classes related to environment configuration and property file management. For example, reading URLs, credentials, timeouts, and browser types from the config properties file. We also have a config manager.java utility that loads these values dynamically based on the environment we are running in, like QA, UAT, or staging. Number 2. Core folder. This is the engine of the framework. It includes essential setups like Drive Factory, which manages WebDriver initialization, Wait Utils, which handles explicit waits, and other base classes that define the foundation of the test setup, such as opening browsers, handling sessions, and taking screenshots when tests fail. Number 3. Pages folder. This is where the page object model comes in. Each web page or module of the Priceline application, like search page, booking page, payment page, has its own Java class. All the locators and methods related to that page are encapsulated within that class. So if there is any change in the UI, we only modify that one page class instead of touching the test scripts. Number 4. Tests folder. All the TestNG test scripts live here. These are the test classes that call methods from the page classes to perform end-to-end scenarios like flight booking, cancellations, or payment validation. Each test file allows a clean naming convention and uses TestNG annotations like @test, @before method, and @after method. Number 5. Utils folder. This folder contains reusable helper utilities, for example, classes for reading Excel or JSON test data, handling API calls, database validations, and capturing screenshots. These utilities are shared across multiple test cases and pages, keeping the code dry. That means don't repeat yourself. Number 6. Data folder. This is where our test data and Pojo classes are stored. Pojo is basically plain old Java object classes. We use JSON or CSV files for dynamic test data, especially for search inputs, booking details, and payment information. Number 7. Reporting folder. All our reporting integrations are handled here. We use Allure reports and Extent reports for HTML reporting. This folder has the setup for report generation, logging configurations, and listener classes that capture tests even during execution. Number 8. Resources folder. Under SRC main resources, we have config.properties, log4j2.xml for logging, and the test data subfolders that holds Excel or JSON data files. This is also where we manage environment specific data. Number 9. testng.xml file. This file defines our testng suite structure. It groups test cases into suites like smoke, regression, or critical path, and it allows us to control which tests run on which browsers or environments. This file is also used by GitLab CI to trigger automated runs as part of our build pipelines. Number 10. Supporting folders. We have a drivers folder for WebDriver binaries and an Allure results folder where Allure stores raw results after each run. The .gitlabci.yml file at the root defines our pipeline. It handles build, execution, and report publishing automatically. So overall, this framework is modular, lightweight, and CI/CD friendly. The structure makes it very easy to maintain, scale, and onboard new test cases. And because it follows POM, TestNG, and utility-driven design, it proves stability, reusability, and fast execution within our continuous integration environments. Now I'm going to explain the framework overview for Priceline in simple plain English. It's a hybrid automation framework built using Selenium WebDriver with Java, and it combines multiple approaches like data-driven testing, modular design, and page object model with support for CI/CD integration and reporting. The framework is designed using the page object model, which means each web page in the application is represented as a separate Java class. All the locators and actions related to that page are stored inside that class. This makes our code clean, easy to maintain, and reusable because if something changes on the UI, we only need to update it in one place. For test execution, we use TestNG. It helps us organize our test suites, run tests in groups like smoke or regression, control execution order using annotations, and also run tests in parallel across browsers. We've implemented data-driven testing using Apache POI, which allows us to pull input data directly from Excel files. This helps us run the same test with different datasets without changing the code. Then we have utility classes. These are reusable helper files that handle common functionalities like browser setup, waits, taking screenshots, reading configuration files, and logging test steps. All our environment specific data like URLs, browser type, and credentials are stored in a config properties file. So we can easily switch between QA, staging, or UAT environments. For build management, we use Maven. It manages all dependencies, plugins, and allows us to trigger test via simple Maven commands. It also integrates with Jenkins and GitLab CI/CD pipelines, so our test can automatically run after every build or code deployment. Once execution completes, test results are published directly into Jenkins. For reporting, we use extent reports and Allure reports. These generate HTML reports with screenshots, logs, and execution history. For debugging, we use Log4j to record detailed logs of what happened during test execution. The framework also supports parallel execution and cross-browser testing using TestNG XML configuration and Selenium Grid. So we can test on Chrome, Firefox, Edge, and even run tests on multiple nodes in parallel. So overall, This framework is modular, data driven, scalable, and CI CD ready, which helps us achieve faster execution, better maintenance, and full visibility of quality metrics across the team.